here to just introduce you what is science inquiry method. You may notice when you go to teach, student teaching or observation or practice, you will find some resistance from your partner teacher. You may not. Also, it is true that they are already familiar with this method. But in order to engage your classroom management, if you involve them in the way of finding something, they will be excited. And that's the reason I want you to just open an area where you can use your expertise and your judgment, and then you can use this method effectively. Okay, so first I open the discussion that how many drops of water a penny can fit without overflowing, This is the first opening question. I do not want them to start right away. I want them to predict. Why I want them to predict? Because I want them to take responsibility, ownership of the process. So if you predict something, then you have a notion that my prediction has to be right, And then when you find out your prediction is right, you say, well, I did it. If your prediction is not right, then you start thinking why I was not right. And this question causes some disequilibrium in your brain. What you used to know and what you know after the experiment, that causes a disequilibrium. And you have to find out that how I can address this disequilibrium by finding the truth. So now it is your job to get a penny on the desk and the paper towel ready for that, because you know you will have a mess on your desk. You will be working in pair, and over there, please pass it on. And first you tell me that what you think. You can consult with your neighbor and tell me, this is group 1, group 2, group 3. We do not have group 4, right? Or if you want, you guys can group 1, group 2, group 3, whichever way you want to do it. So if you are group 1, then talk to each other and tell me that how many drops do you think the penny can fit without overflowing? Predict.
Like in the, I'm confused. Like in the, oh, like put it on the penny? Okay. I said 2. Okay. Like 3. Okay, yeah, 3.
3? Okay. Group 1. This is, I had water, trial 1, trial 2, trial 3. So prediction is 3. And this is before, and this is after. So we will fill up these after we finished. Next, group 2. No, not you.
Yeah. So I'm like, she already knows. I'm gonna say like 5.
5. Group 2, 5. Before, group 2, 5. Group 3, 4. Okay. Group 3, 4. Okay. Now, it is your job to start working on the experiment, which means you start adding water on the penny. Start. If the drop is landing outside the penny, disregard it. I can see group 1 is still doing. Group 2, how many?
I got 33.
Average it. Whatever you have and she has.
27. 27.
25?
27.
27.
27?
Yeah, that's the average. We did 20.
Group 3? Average.
25.
25? Okay. I'm sorry, this is not the right one. Yeah, it was right. Okay, you can see that your prediction was 3, and there is a difference of 17 drops. There is a difference of 22 drops. There is a difference of 21 drops. Did you see that the prediction? Now, if you are going to do again, what will be your prediction?
Higher.
Higher. Give me a number.
Um,
Group 1, give me a number.
23.
Yep, that's
23.
20,
23.
23,
Yes, ma'am.
23. Then group 2, give me a number.
I'm going to go with 30. 30.
Very optimistic. And group 3.
I would say like 35.
35? Wow, let's see. Let's
That's the
see.
most optimistic.
Okay, let's see. Start. You have to do it again.
Got 31.
You have dropped too many drops at a time. Remember, you are doing an experiment. You are trying to take care of the experimental error. You are human being. It is okay to mess up. But as a scientist, you want to be accurate as far as possible. So if for any reason you think that you have messed up, no problem. Start all over again.
I got 27.
You have to stop at the point when you see that it is overflowing. So stop at that point. You have to go until it overflows. See, it is still taking, that's it. So that is your final number.
You got 39. Jeez.
I guess it just depends on how you always.
Yeah, it really is like a strategic placement.
Okay, group 1, have you reached a final number, average?
27. No, it's 30.
You're on 27. I'm on
Yeah, just
27
27.
and 39.
Yeah.
You're on 33.
33.
33.
We got the same thing.
Group 2,
33. We got 33 too.
14? Okay. Okay. Now, how the students are learning, how do you know? At this point, how do you know that your students are learning? Suppose I am using this data to gauge if my student is learning or not. Look at this. The prediction was 3, and this group found out from trial 1, 20. There was a difference 17. Now, if you compare these two numbers with this number, it is 10. Obviously, the student made a legitimate guess. The guesstimate is very close to the final number. So it is, the difference is 10. Before that difference was 17. Before here, the difference was 22. Now it is only 3. And the difference here was 21. And for some reason, this group got lower than the previous number, the prediction. Why do you think it happened? There is no such thing, right or wrong. Always gear the student towards the final objective. There is no right or wrong. Many times when I give workshop, they ask me, the candidates ask me, what is the final answer? What is the real number that we should looking at? No, there is no such real number. It is the process. It is the process. It is the thought process I'm working on. Therefore, I can see here that for some reason they got lower number. Now let's figure out why they have the lower number. What do you think why you have lower number?
Because the first time we didn't know what to expect as far as the process goes. Like we didn't know how to put the water onto the penny. And then the second time we kind of got more idea of what we were doing. So we kind of got more expertise.
Precise.
Exactly.
So second time you became more precise. See, when you are doing an experiment with the students, you have to tell them that there are two kinds of variable. Dependent variable and independent variable. Look at this, what I am introducing here. I am introducing not only water density, and I will come up with the density explanation right after this. But first you see I am emphasizing on the research process. I am helping them to try to understand what is research process. With this one, the dependent variable is what? The final number of drops. But the independent variables like that can mess up your experiment will be what? Think.
just want us to like list?
Hmm?
You want us to like list things?
Yes,
The type of dropper that you use.
exactly. Anything else you can add to this?
Maybe if like your penny is more like black,
Like worn.
yeah, worn
Kinda
down
like
or
a-
new.
Yeah,
And-
a newer old penny.
You? What do you think? Add something to this, whatever they have told you.
How much, like, water, I guess, like, you put in your thing, and then, like, yours drops, how it drops, like, you can do multiple, but you're, like, on accident.
Okay,
Countertop too, like if you're on like a flat surface, or if you're on like a carpet in my backyard, or like a flat table or something like that.
very good thinking. And speak louder so that she can
I'm sorry.
catch. Okay, there are more ideas, not right or not wrong. Which side of the penny you are using? You already told me that it might be rusted. And you told that the dropper, the shape of the dropper, and also it depends upon how far you are putting your hand, how it is landing on the drop. So I saw you were holding your hand like this. Why did you hold your
I
hand?
guess to steady it.
Good thinking. She made it like steady drops. So these are the things that you need to think. Also, you can introduce the penny as a discussion, social study, as a discussion that whose face is there and what the penny is made of. Copper or mixed with other metals. And if you are teaching grade 4, you might introduce something that when a metal is mixed with another metal, it is called amalgam. So there are so many things, and then you can touch on social studies, that whose face is there on the penny, when did it happen, when this penny, we have decided in the Constitution that whose face will be on the penny. So you can introduce so many things. Now, what happens? Another very important thing I want you to consider. What was the structure of the water on the penny? What is the shape? Oval. And why is that? Why is that?
Well, it's what? Like,
Louder.
Why is what? I don't understand.
I'm asking that what shape did you observe about the water on the penny?
I was like the water itself is like the same shape, like it takes the shape of
What is the shape?
oval.
Oval. And why is that?
Probably because the penny's an oval, so it takes the shape, water takes the shape of it.
Okay. Why is that? Why it is not flat, it is oval? Why is that?
Probably because of the what's on the penny, like
On the penny. Okay. Let me start with this. This is my first idea about introducing an inquiry lesson. We are done with water, and we have found that the water drops for different group are different, number one. Number two, we have seen that there are some experimental error we should take care of. Number three, we should know what is independent variable, what is dependent variable. Now, we are stuck here asking question to ourselves that why it is making a dome shape rather than a flat surface of water. So I want you to come here and stand in a line holding your hand. Come over here.
please.
Hold your hand.
Each other's hand?
Hold your hand up. You have to stand in straight line. Therefore,
Oh, you got to back up.
yeah, spread as much as possible.
How long does it take?
Okay. Okay, now you are in a straight line. Suppose you are a hydrogen atom and you are oxygen and you are hydrogen and you are oxygen. You are hydrogen and you are oxygen. Why I am doing in terms of hydrogen and oxygen? Because water is made of what? Hydrogen and oxygen. How many hydrogen atoms? 2. And how many oxygen atoms? 1. Therefore, the formula for water is H2O. Great! Now, you are the oxygen. Come one step forward. Do not lose your hands. You are the oxygen. Come forward. So, hydrogen, oxygen, hydrogen. Oxygen, hydrogen, oxygen. So, what you have seen in the dome structure, that is the oval structure, that water is, when you are adding up water, it is making dome, right? It is not going this way or it is not going that way. It is making a dome. Therefore, you cannot move. You have to stay where you are. And you cannot move. This is the one side of the penny and that is the another side of the penny. So both sides of the penny. Then what happened when you added more and more water? What was happening? It was making a dome structure. Therefore, you guys, all of you guys have to come forward, not you, not you. And then forward, forward, as I am dropping water, forward. Now, what structure it is forming? Oval structure. And this hydrogen bonding, if you like, you can introduce that he is a man who is married to her and she has affair with this man and this man is already married to her, but you have an affair with this one and you are already married to her and sorry, you don't have any choice. Okay, now as you keep on adding water, you are coming forward. You are coming forward, but she cannot move, she cannot move. And this bond is called hydrogen bonding. In water, they are so tight. All the molecules you have seen, even though you are adding water drops one after another, they are not breaking. They broke at the point of 27 drops. So it is trying to accommodate as many as water molecules possible. And this is called cohesion. This is called cohesion. You have learned this in your high school. This is called cohesion. In water molecule, they are called cohesion. But that fellow and that fellow, they are stick to the penny. They are not moving. So water has a natural tendency to stick to the surface, whatever surface it is. So this is called adhesion. So in the board, you can start writing that what are the concepts we have started. You can go back now. We talked about penny, that is social study. Social study. We are integrating this lesson is multidisciplinary. In lesson plan, when you are writing, then it asks you that what other areas you are introducing in your lesson. Is it purely science, or it is integrated with other disciplines? Yes, it is integrated with other disciplines. Here you can talk about the face and why this face, when it was decided that whose face was there. So it will be something like 1766, say for example. Then you are talking about variables. You are talking about variables. You have talked about experimental error. Experimental error. Then we switch totally to hydrogen bonding. Hydrogen bonding. Then we talked about cohesion. Number 4, number 5. Number 5, cohesion. Then number 6, addition. Then number 7, we call it surface tension. The whole thing that you observed, that was combination of cohesion, addition, hydrogen bonding, and the result is surface tension. Now, let me give you an example of surface tension. Why do you think how the water molecule, how the plant, how a tree gets water molecule? From the air, from the ground, none of the above. Tell me, where the plant gets water from? Ground. So it takes the water molecule, it sucks the water molecule from the ground. If it does that, how the water molecules go up to the top of the plant, defying gravity? How does it happen? Louder.
The roots.
What is the mechanism?
It absorbs it.
Hmm?
It absorbs it. I
Yes,
don't know if that's what you're looking for.
connect to the activity. So,
The dome.
yes, surface tension, something is sucking, right? And it doesn't get anywhere to go. So it is following the tube. Tube means the trunk of the plant. It is going top there through surface tension. So you can use any example that you can find. Okay. How are we doing as far as time? How much time I have?
You have until 11:40, right?
Okay, 11:40. So, up to this point, I'd like to ask you, where do you see the difference between a traditional lesson plan with an inquiry lesson plan so far?
A lot of it's up to the students. You know, like the teacher can't like plan all the conversation that's going to happen in the class because it's kind of like, what do you think? And the kids start giving the examples that, you know, I guess it's more student based.
Student oriented,
Yeah.
right? So the teacher, what is the teacher's job here? What is the teacher's job here?
To guide the students. To guide the students.
To guide the student, to facilitate the discussion, right? Did I give you any answer that no, you are right or you are wrong? Yeah, exactly. You have to know. You have to decide whether you did it right, or if you didn't, then what it can be, how I can do something better than that, instead of teacher telling you that you are right or you are wrong. You are deciding yourself. That I was able to create a disequilibrium in your brain. You say 5 drops, 3 drops. Then I said, okay, go ahead, do it. So the process, the result that you found, 25 drops or 27 drops, it's not a big deal. You drop the water and you see, okay, fine, it is, I said 3 and it is now 27. So what is the big deal? Big deal is that you have to catch that aha moment when they are seeing that they are wrong or they were not right about predicting something and what is they have experimented. Then they start asking questions. And that questions, when they are asking questions, then you take them over there, as I told you, that this is the reason it was making a dome structure instead of being flat, because of hydrogen bonding, because of, look at the board, cohesion, adhesion, and then surface tension. And then I gave you a practical example of surface tension. So in regular lesson plan, are you done with this? Can I erase it? In regular lesson plan, you start with I'm not going over objective, like you know how to write objective, right? By this time you know how to write objective.
Yes.
Yes, yeah, I wanted to hear a louder voice. Yes, we know. So in traditional lesson, and in inquiry lesson, let's compare that. Here we start with set induction, correct? In set induction, and here I will say that I engage the students in a conversation, that this is what you are going to find. Here, you know that this lesson plan is about density, and you might tell them, today we are going to find out about density of water. Here, you do not say that. You just let them do, and you engage them. Next is, here they are doing experiment, right? Here, you are doing experiment, but this one is teacher guided. You have a worksheet and it tells you what to do, right? You will be given a worksheet. Here, you make your own worksheet. Am I correct? Because this is our worksheet in inquiry. But if it was set induction traditional method, I would have given you a paper worksheet and you could have found it. Next is, what you are doing, the next is, at the end of the worksheet, you do discussion. Here, it doesn't end there. It is question and answer. Question and answer. You are doing your work. Teacher is not doing your work. You are trying to find out all the question that why it is dome structure. So you go back to your experiment. Therefore, here you revisit the experiment. First you are trying to think that why it is dome structure. Then from that hand holding, you are getting the idea that two sides are fixed through addition. And if you keep adding water, it is going forward. And you have seen that actually how it is making a dome structure. And then we talked about if that is making a dome structure, then it is an example of cohesion and adhesion, and then finally surface tension. And then we gave you an example. So up to here, over here, after this, what you do in traditional lesson plan? Tell me. This goes as explanation. This goes as explanation. Am I correct? Discussion, what do you call in traditional lesson plan? This part? Set induction, then what is next? Traditional lesson plan, the way you write your lesson plan. What you do next? What you call it? Stop playing with the drops. Hands down. What you call in a regular lesson plan? How do you write your lesson plan? Tell me. How do you start? Objective. Objective. What is next?
Like an attention grabber.
Louder.
Attention grabber.
Very good. How it will match with this? Right? Attention grabbing is something comes under set induction. Then what do you do? What do you do next?
You actually teach, like,
Teach the lesson. Here you are teaching the lesson, right? Then what do you do after teaching the lesson? In a traditional lesson plan.
You like make sure they actually learned it.
So you ask question, right? You ask question and answer. Then what is next after that? Individual assignment, right? So you give them individual assignment. But here, I am not giving you individual assignment. I know that does it mean that you are not responsible individually for any kind of worksheet or any kind of knowledge you gained? You are not individually responsible? Are you not individually responsible in the inquiry? What do you think? I will let you go even though I know that you have not taken any individual responsibility. Is it possible? Possible? I should let you go?
Some teachers probably would, but you shouldn't.
Okay, no, I do not let you go without doing it. So I give you another assignment to understand whether you learned the concept or not. So, if I ask you that if you add some liquid soap in water, will it have the same result on penny as far as number of drops is concerned. So here I say water plus dish washing liquid. And then I ask you, I am trying to see whether you have learned anything from the prior experiment. So I am asking you, if you add water, if you add dishwashing liquid to water, what will be your prediction that how many drops of water mixed with dishwashing liquid a penny may fit without overflowing? Now you have to predict here. Again, what do you think? It will be less or more or same?
15.
15? So here you are thinking that last time you found 33, you are making an educated guess that it will be less. We will come to the reason why you are thinking like that. Let me get all the data from you guys. Group 2, what do you think?
I think like 8.
Huh?
Like 8.
8? Okay. And group 3?
10.
10? So I can see here that you are making an educated guess based on your prior knowledge that you just gained here after doing the experiment. You think it is less. Now tell me, why is the reason? Why do you think it will be less? Why?
It changes the substance of the water.
It changes?
It makes it, I mean, I guess like you could say, like, it almost makes it like thicker. It makes it, it's a different, like, I can't think.
The density.
Yes. I was
Density.
about to say volume, but I knew volume wasn't.
It is changing the density. It is
Yeah.
obvious that it is changing the density.
And also matters how much soap you put in the water, too.
Uh-huh.
So,
So, since you have predicted, I want you to put some water in the glass. That's enough. That's enough. And I am adding some liquid soap in your water, and never drink the water. That's the caution, that's the safety. You always have to emphasize that this is not allowed. You cannot drink or mess with soap water. They will love to play with soap water, making bubbles. So you just stir it. You just stir it and see if it is making the same number of drops that you have predicted. And Dawn is the best you can use. And I forgot to bring liquid Dawn from home, so I used whatever they have there. So when you are doing the experiment with the students, bring Dawn.
Yeah.
Oh, I'm sorry. Oh, okay.
Thank you.
I got 15 before the third one off.
Okay, I can
Yeah,
see
I
group
got
1 is
15
ready.
too.
Group 1, what is your number?
20.
20?
It's going to be 13.
13?
27.
27? Okay, I want you to go for another trial. Actually, when you are doing with your students, you need to do 3 trials. Always remember, when you are doing experiment, 3 times you have to do, and then take the average. Right here, I do not need to, so I am making 2 trials. But for your practice in the classroom with real students, you have to make 3 trials. What is trial 2, group 1? What is the average?
15.
What is the average?
18.
What is the average?
22. So yeah, so it's like 30 divided to 15.
15? 15. So if I add this 20 plus 35 and divide it by 2, it will be 17.5. If I add 13 plus 18, will be 31, divided by 2 will be 15.5. And if I add this one, 42 divided by 2 will be 21. Therefore, now if you compare these numbers with your trial 2 numbers, that this one obviously had some experimental error, but in the trial 1 it has 25 and now it has 21. Now here it is 15.5 and here it was 13. Am I going? No, this one. 33 and now it is 15.5. Here with 33 and now I have 17.5 for this group. So you can see that the dishwashing liquid is changing the density, which means give them some practical examples. Why? When we are washing our dishes, we do not wash only with water. We rinse it with water. But if we really want to make it clean, then we need dishwashing liquid into it. Why do you need dishwashing liquid if water can clean it? Because water cannot clean everything. That's why you need dishwashing liquid. The job of dishwashing liquid is to break the hydrogen bond. Suppose you are making this line and I am the dishwashing liquid. I can go there and break the bond. As you said, the density has been changed. So I break the bond. And what does it mean in terms of cleaning, breaking the bond? It goes right into the dirt. It goes right into the impurities or food particles. It hits there. But if it is done only with water, it doesn't do deep cleaning. It just rinses it. But if you really want to get it cleaned, then you want dishwashing liquid to break the hydrogen bond the thin layer on top of the dish. You break it and you clean it. That's why you are using dishwashing liquid. So, see how I have categorized them. I have engaged you in a discussion. This is engagement. This is called engagement in inquiry lesson plan. This is number one. Then you did experiment. That is called exploration. Number three, I gave you explanation for all the things that we have observed here. And I am continuously revisiting your data. I am working on your data. I am not working on my knowledge. You are not testing my knowledge. I am testing the working data that you gave me. I am working on that. And based on that, I explain to you that why it is coinciding with your prediction or why it is not. What are the reasons? Then, after explanation, I asked you, I gave you a new challenge. If I add, hands down please. If I ask you that if I add dishwashing liquid, what will be your prediction? Again, I want you to take ownership of this activity. You cannot just sit quiet there and pretend listening and actually not listening. I am engaging you. I am constantly asking you questions and not giving you the right answer. If you are not giving the right answer, I am throwing back another question. And finally, I will be able to reach my objective by answering and questioning and answering. It is very easy for the teachers, you know. If you ask a question and the student doesn't answer right, you give the right answer. You give them the right answer. No big deal, I gave the right answer. So there is no confusion. Teacher did his or her job. But here in inquiry, you do not give them the right answer. You guide them towards the right answer so that they come up with the right answer, not the teacher gives you right answer. Therefore, I gave you a new challenge in extension. And then number 5, I give you evaluation. Here, your individual accountability works. You thought in inquiry lesson it is free-wheeling. No, it is not free-wheeling. Still, you have the objective in your head and you are making sure that they are reaching to the objective through all these steps. And in evaluation, you can use the same evaluation that you have used here under individual assignment, or number 5 is evaluation. In traditional method also, you have evaluation, right?
10 minutes.
Okay, these are the 5 steps of inquiry. And it is called 5E cycle. Guys, you will be facing this when you start your real teaching. You have to. According to the state standards, Louisiana state standards, you have to do this. It is not anymore experimental. This is mandatory. If you cannot show your supervisor that you do not know about 5E cycle, you do not pass your first year evaluation. You have to learn this. The 5 steps. Number 1 is what? What?
Engagement.
Engagement. Number 2? Number 2,
Exploration.
exploration. Number 3,
Explanation.
number 4,
Extension.
number 5.
Evaluation.
Okay, now I go back. What is, you said engagement. What was the engagement in the inquiry lesson? What part was the engagement?
The predictions.
Yes, prediction. I engaged you in asking that how much do you think? Then exploration. Which part you think will fit into exploration?
Doing the experiment.
Doing the experiment. Which part will include explanation?
I'm explaining why, whenever you did the first experiment, why it's like, was a dome shape, and whenever you mix the dish soap with the water, it
Water.
changed.
I'm coming back later. What will be the extension?
Adding the dish soap.
Adding dishwashing liquid. So there is a difference. The boundary is exploration and the new challenge, which is extension. And then evaluation. Do evaluation the way you do in regular lesson plan. Anything you can do. Got it? Done. Okay, we are done.